Now we're going to practice using this notation, which explains that we are going to find the area between a curve or some functional line, the x-axis, and x equals 1 and x equals 3. Now, so far we haven't looked at exactly how to integrate, so we're going to use something that we already know. We'll use the area formula. So the key thing to do here is to think about what our question is asking us. We're looking for the area underneath a curve, and the easiest way to solve these problems is to draw them. Now here we have our function. We have the function x plus 2. What that means is f of x is equal to x plus 2. And you know that's the same thing as writing y equals x plus 2. How do we graph this? Well, it's a straight line with a gradient of 1, so it's going up at 45 degrees, and it's been lifted up 2. So I know it goes through the 2, it's got a gradient of 1, so I can put this in something like this. All right, now we're finding the area that's between this line and the x-axis, but we only want the part between x equals 1 and x equals 3. So the next thing we do is draw those lines in. X equals 1 and 3, and we could put in some lines. All right, so we're wanting this area here. Now there's two ways we could go about this. We could say, hey, that looks like a trapezium. So I'm going to use the formula for a trapezium, which says area equals half the height times the top plus the bottom. We could also say, well, we'll break this up, make a rectangle and a triangle out of it. Find the area of the rectangle, the area of the triangle, add them together. You can take your pick. I'm going to go with the trapezium method here. Now, the parts I'm going to need for my trapezium formula, I need the top and the bottom, which this is the trapezium on its side, isn't it? So I'm going to need this height, and the height of the trapezium is actually going to be the width here, which I can see is 2. So I've got a length of 2 there. Now, how am I going to figure out how long this is? Well, I know that I've got a gradient of 1 here. So if this is going through the y-axis at 2, then as I go across 1, I will have gone up 1. This is going to be equivalent to 3. So I can see that this line is 3 units long. And if I've gone across 2 more squares, if you like, I must have gone up 2 more. So this is going to be level with 5, and I can see that this is 5. So now I can come back to my original question. Let's just rewrite the question so we can see how our setting out would look. This is the question we have. And we've drawn a picture to understand what it is that we need to do. Now I'm going to go ahead and put in my area formula. So I need the height divided by 2. Well, the height is 2. And then I need to multiply it by the top plus the bottom of the trapezium. So I've got one lot of 3 plus 5, so I've got an area of 8. And this is the answer then to my question. Now this example is giving us a function that we will have seen before, and hopefully you can recognize that it is a semicircle. Now if you're not sure, writing it out like this, when you square both sides, you're going to get this, and rearranging it, you can see that it's very similar to a circle that has a radius of 4, and its center would be 0, 0. But we haven't got the whole circle. How can we tell? Well, we squared both sides here. The original function that we've been given says y is equal to the square root of this stuff. Now, square roots are always positive, so that means we only want the positive part. So what we're dealing with here is only the top half, where y is positive, because y needs to be positive here, of this circle that has the radius of 4. So our question is saying, all right, we want to find the area underneath this semicircle, but just between x is 0 and x is 4. So having a look here, when x is 0, we've got this, and when x is 4, we've got this. So in other words, we just want to find this area here. And see how our picture makes sense of it. So without working, we can just hop straight into saying, hey, this is a circle. I know how to find the area of a circle. Area is equal to pi r squared. I'm just jotting this down on the side. And I know here that the radius is 4. But I don't want the whole circle. Seems like I only need a quarter of the circle. So I'm going to put that in. I need a quarter of pi r squared, where r is 4. So this gives me 1/4 of 16, which is 4 pi. And I can leave it like that. It saves me from reaching for my calculator, which takes time, and saves me from needing to round it off and have an answer that's not actually exact.